Okay. Client states that we have a straight 50, not a 50EX, so I guess you'd call that a 50B, that's refit to ProLine 21. Aircraft is always slow turning left. They get a, I have not seen the error message, something like an aileron mistrim with an arrow. I have not seen that video. It came in low resolution. They do get this with every aileron input to the left. So I'm going to assume that means heading select, or that also means FMS course change, or just any, from what I understand, it's anything that causes the autopilot to turn left. It is extremely slow to react. It's normal to the right, and I'll be interested to see if that squawk, if I'm describing that squawk correctly. I'm assuming there is no difficulty in the flight control system, that the airplane flies smooth as a pin, left and right. In the ADI in front of the pilot, you have a coupled left, coupled right arrow. And for now, I'm assuming that coupled left we have the problem, and coupled right we have the problem. That does not affect which flight guidance computer is driving the flight control circuitry. In other words, it doesn't matter if it's the left course select that's causing it or the right heading select that causes it. None of that's significant. So that's the description of the squawk. Like I always do, I'm going to do Todd's perfect world. So we're going to go right to, we're going to call this a servo motor right here. Okay, what does it take to make a motor turn? Well, in this case, it just takes a plus and a minus. The servo motor is a simple DC motor. And, you know, somewhere in the airplane, you must have a circuit breaker, and somewhere you must have a ground. Okay, that's what makes this motor turn to the left. Now, ideally, there would be a print that would show exactly everything that's in here that causes this servo to turn left. We're going to find out that it's in the IAPS, which is the large avionics cabinet. And we're going to talk about two flight control computers. Just from some old ProLine 4 memory, I'm recalling that one FCC provides the power, which is here. One FCC provides the ground, which is here. There's going to be some other stuff out here. And that's what makes, in some way or other, we come through a power supply board, we come through some other trickery, and somehow or other, this is what we're going to detail. Something is causing the motor to drive strong to the right and weak to the left. Now then, the cannon plug that disconnects the servo, SVO 80, whatever it is, we need a picture of this cannon plug, because we're going to end up backpinning this cannon plug to try to figure out which drive is weak. Now, all of this has been changed. The servo's been changed multiple times. The FCCs have been changed. The IOCs, I think, if I understood the conversation right, the IOCs have been changed. So what I'm suspecting is there is a swap, and the swap affects the problem, but unless you have a voltmeter on these pins right here, you cannot detect the problem. In other words, if the failed one's here, it looks like the left drive is weak, and if the failed one's here, it looks like the left drive is weak. I would imagine that's what's going on. So first thing we're going to do is get a drawing that looks like this, that has a ton of detail on it, and then we're going to talk about breaking into this plug, and the other thing we're going to talk about, obviously, this motor goes out and drives the actual physical airplane, which I think first is an Amity, and then a Q, and then a hydraulic, the real servo, the hydraulic servo up underneath the, mounted to the front spar of the wing. So we're going to get a detail like this that looks, that has actual pin numbers on it, functions, features, logic inside the FCC. We're going to look at all that, try and get all of that onto one piece of paper, and then we're going to talk about some troubleshooting potential here by observing these two voltages. Okay, we introduced in the first little bit there, we introduced the problem. F50 will not turn left with the autopilot. Have a couple of new things there. The pilot thinks he can feel a little bit of roughness in the controls. So what we're going to do is we're going to try and isolate the difference between electrical servo drive this way and then the actual mechanical system on the airplane, which is like, you know, the yoke is here, and then a bunch of bell cranks. I think the Amity is here. Amity. And then we go out to a Q unit. And then we go out to the split for the two wings. I think the trim. So there's an artificial feel unit spring here. So one of the things we talked about is if there's any possibility that it's this capstan right here mounted to the servo, I just found out that this capstan has not been exchanged. So I think one of the most important things we could do is probably pull this tie rod off of the capstan and then see if we can figure out if the capstan is free to move in one direction and hard to move in the other. I think this mechanical thing deserves a little bit more looking at, focusing on this capstan or maybe even this AFU right here. Could be possible that the AFU is super stiff in one direction and loose in the other. But back to the electrical, I'll try and go through this quickly. The IAPs in the nose, what we're going to concentrate on is the aileron servo, pin A, and pin B, okay? So what we have is called an H-bridge, and I'll explain the H-bridge at the end. But what happens is one flight control computer here, one FCC here, and on this drawing, this happens to be FCC number 1. One FCC number 1 drives, so this is an output amplifier. This is an output this way. It drives. In our case, let's just say, for example, that was the minus. So this FCC goes out and drives the minus side of the motor. That may be either way. I'm not sure, plus or minus. Now, the number 2 FCC has the same circuit. So the number 2 FCC drives this way. And in our case, maybe let's say that might be the plus. So each FCC, one FCC drives plus, one FCC drives minus, and then when the ailerons go the opposite direction, the opposite is true, and I'll be back. Okay, and my friend just stopped by and reminded me, I didn't know this. There is a work card to grease this capstan, and the grease should not be Mobile 28. Remember 2-3 years ago you could not get 7, so you might look at that capstan and make sure it's not greased with red grease. This is pretty good suspect right here, mechanical problem out here beyond the servo or at the capstan or whatever. So let's go through and do a little explanation on this. Plus side, minus side. One card provides one side of the motor. The other card, FCC2, provides the other side of the motor. Now then, when this card drives this signal here, the number 1 drives this signal, it also sends the signal to flight control number 2, so it monitors. Each card knows what the other one's doing. Okay, so what we want to do is we want to figure out a way to get into pin A and pin B right here on the SVO. So there's a couple of different ways. If you have a breakout box, I think I just got news from the client that he does have a breakout box. You have an option if you don't have a breakout box. You can't, let's say, for example, this was the airframe. This has nothing to do with it, but if this was the airplane harness, you can disassemble the back shell, disassemble the strain relief, and then put a extractor, the push end of an extractor. You can stick it into the pin. Obviously you don't want it touching metal, but you can stick it into the pin till it touches, and then you can clip lead to that and then plug it right back into the servo, and then with it plugged, now you would have access to pin A and pin B if you don't have a breakout box. I've got a couple of pictures of that. I'll put the link. So basically, here's what we want to do. This may be what's called pulse width modulation, so a flute meter may not be happy about this. So what we want to do is come into pin B and pin A, and let's just go to a regular old Simpson meter with a needle, okay? Now then, when you drive it hard one way, you'll get needle movement. Now then, when you drive the autopilot the opposite direction, you'll have to swap the leads because this needle will drive backwards. But this is where I would go right now, is I would leave hydraulics off the airplane so the servo actually is stalled. It's actually locked. It won't move. And then I would go left turn command and see how far this goes, and then swap the leads and go right turn command and see how far this goes, and see if you can define out if electrically these are being pushed hard. And I'll explain what an H-bridge is in a minute. Now then, if we find out these are different, so like your plus to minus here is like, you know, plus, maybe it's 14 volts, maybe it's half voltage, but when you're minus on the top, plus on the bottom, you're only getting, you know, 4 volts or some ridiculous difference. Then we're going to go this way into this wiring, like possibly a partially grounded, one of your leads is partially grounded, something like that. Scraped wire. We're going to get real interested in what's happening in these flight control cards. My theory is that you can swap flight control cards, and even though you've swapped the problem, the way the pins work out, pin C, and I don't know what the other pins are, it's possible that it could obscure that you actually, that a swap will not identify which way the aileron servo goes, weak one way and strong the other. So the other thing you can do, you can go like from pin B, you can go to a regular flute meter. You can go like from pin B, you can try it into a flute meter and then just put the other side of the flute meter on airframe ground and see if when this side goes low, how low does it go? And then when this side goes high, how high does it go? Does it go to like 14? And then vice versa. You take a flute meter, put it on A. When this side goes high, how high does it go? When this side goes low, how low does it go? If these numbers look pretty balanced, I would push you back out towards a mechanical problem, like a capstan dragging or some mechanical problem out farther. I think this is the next thing we need to identify. Are we getting electrical drive out of the IAC that is fairly much the same whether you're left drive or right drive? And I think that's it. Okay, we were going to go through an H-bridge a little bit more carefully. Let's say this is a motor right here. And let's say we have, like, you know, you got to, what do you have to do to make a motor turn? You got to put a power and a ground on it. Let's say this is a transistor. We're not going to worry about that. We're going to just call it like a switch. Let's say this is a transistor. We're going to call it like a, it's just like a switch. We're not going to worry about that. Let's say this one goes down to ground. Let's say this one goes up to plus 28 bus power here. Okay, this is a switch. Just call that a switch. Let's say this goes up to bus power right here. Let's say this is a switch. This goes down to ground. Okay, see, these are just simple switches. Now then, you can imagine if you want the motor to turn one way or other, let's just say to the right or just whatever it is, you would turn on this switch and this switch, and you would leave these two turned off, let's just say, okay? Now then, That puts bus power on this side, nothing to ground, and it puts ground on this side, nothing to power. Okay? If you want it to go the other way, let's say you would turn this on. That puts bus power over here, which makes this the plus side of the motor. And then over here you would connect this side to ground, which makes this side the ground. So it would be like that. It would be like power on this side, power, ground on this side, ground, motor spins the other direction. That's what they're doing on the FC, on the SVO. Okay? In our case, obviously, the SVO is out here. It's pin A and pin B we learned about. So let's just imagine that we take pin A here, and we take pin B here, and this is what we got. And then what they've actually done is they've called this Flight Control Computer 2 and this Flight Control Computer 1, and that explains how one autopilot provides one half of the drive and one autopilot provides the other half of the drive.